Welcome back. This video is going to be looking at section 1.4, which is adding and subtracting fractions. The result of adding two fractions is called the sum. The result of subtracting two fractions is called the difference. The sum or difference of two fractions with identical denominators is the sum or difference of their numerators over the common denominator. So if A over B and C over D are our two fractions, then A over B plus C over B is the sum of A plus C over B. And if we're subtracting, the numerator is A minus B over that common denominator. Sorry, A minus C over that common denominator B. So let's look at this. And again, we're reducing if possible, which we cannot do until the end. So 3 plus 4 is going to be added together for our numerator. Our common denominator is 11 for our first example. So 3 plus 4 is 7. So 7 over 11 is our answer. Note 7 and 11 are both prime numbers, so there's nothing that they have in common. For our second fraction sets, we have 7/15 minus 4/15. So we need to do 7 minus 4 for our numerator over the common denominator of 15. 7 minus 4 is 3. And so we get 3/15 as an answer. 3 can go into 15 evenly, so let's write 3 as 1 times 3, and 15 as 3 times 5. And here our 3's cancel, top to bottom, and so our answer reduces down to 1/5. And for C, we're adding again. 5 plus 2 will give us our new numerator over the common denominator of 12. And so we get 7/12. And again, 12 can't go into 7 evenly, but can't be broken down any further because it's prime. And so 7/12 is the answer. When adding or subtracting fractions, a common denominator is required. And so when we're looking at adding and subtracting fractions without the same bottom number, without the same denominator, we have to rewrite them in order to have the same denominator to be able to combine them. Because if we think of that visual that they gave us before of fractions with that pie, we can't add pieces unless they have the same size pieces. So for our first example, we have 1/5 plus 3/4. So notice that we do not have the same denominator, so we have to create that. And so there's a couple different ways that you can go about doing this. You can use the prime factorization of them, or multiples, things like that. Or you can just multiply the two denominators together. That will always work, but it won't always be the smallest number that works. And again, using smaller numbers makes it more easy to handle. And so let's see what we can do with these. So 4 can't go into 5 evenly, so 5, the larger number, is not going to be our common denominator. And if we think of multiples of 5, so 5, 10, 15, 20, the first one that they have in common is actually going to be 5 times 4, or 20. So we're going to use that to rename our fractions. So let's write 1/5 here, and we're going to turn it into an equal fraction that has 20 on the bottom. And to that, we're going to add whatever we get when we rename 3/4 into an equal fraction with 20 on the bottom. So remember, we've been working with reducing by canceling a number that's the same on the top and the bottom. And so if we had 14, which is 2 times 7 on the top, and 22, which is 2 times 11, we could cancel those common 2's. We're working backwards. We want to be able to multiply the top and the bottom by the same number to use 20 as a denominator. And so if you look at our first fraction, 5 to 20, what we multiply to get there is times 4. So what we have to do to the top is to do the same thing, because we know that 4 over 4 is just another way of writing 1. They would cancel each other out if we were reducing, but we're making them bigger to have equal fractions with the same denominator. So we're going to do 1 times 4 and get 4 for our top number. So what this is saying is that 1/5 and 4/20 are worth the same amount. We could simplify 4/20 and get 1/5 as an answer. And so for our second fraction, 3/4, we want to change it to an equal fraction with a denominator of 20. So 4 times 5 gives us 20. So that means we'll have to multiply 3 times 5 to get our new numerator of 15. So again, they're equal fractions, and if I reduced 15 over 20, I would get 3/4. And so now we want to combine them together. So we follow our rule of keeping our common denominator, which is now 20, and adding our numerators together, 4 plus 15, and that gives us 19. So 1/5 plus 3/4 gives us 19/20. Let's look at example B. We have 8/9 minus 5/6. And so again, we need to get a common denominator to be able to subtract. And so when we look at 6 and 9, well, 6 can't go into 9 evenly, and so 9 can't be our denominator. That's going to be our like denominator. But let's do, again, our multiples of 9 and see if 6 can go in them. So we have 9, the second one is 18, and 6 can actually go into 18 as well. And so 18 is going to be our least common denominator. And if you get stuck on having a common denominator, remember, you can always do 9 times 6 and use 54 as a common denominator. But in this case, 18 is much smaller, and we would definitely have to simplify if we just did 9 times 6 in this case. But that will also get you the final answer eventually. So we have 8/9. We're going to turn it in to 18ths. And then we're subtracting from it 5/6, which we also need to turn into 18ths. So let's find our numerators. To get from 9 to 18, we doubled it, so times 2. So we have to double, or times 2, to the numerator. And 8 times 2 is 16. Now when we look at our second fraction, to get from 6 to 18, we have to multiply it by 3. And so 5 times 3, or 15, will be our new numerator. So now that we've done that, we can subtract. And so our common denominator again is 18. And when we subtract 16 minus 15, we get 1. So 1/8 is the answer to our problem. Let's look at our second example here. We have 1/4 plus 5/12. So our larger denominator here is the 12, and 4 can go into 12 evenly, and so we're actually going to use one of the denominators as our common denominator for this one. So 1/4 we need to turn into a fraction equaling 12 as a denominator, but 5/12 we get to just keep it the same. And so we'll just copy it over here to make it easier to see what we're adding together. And so for our first fraction, we know to get to 12 from 4, we have to multiply by 3. And so we're going to do the same for the top. And 1 times 3 gives us 3. And now we can go ahead and add already because we have 3/12 plus 5/12. 3 plus 5 is 8. So we're going to get 8/12 as an answer. Notice here that we have 8 over 12. They're both even, so we know they can be simplified. And you can either break it down into prime factorization, or again, think of what we can multiply. And if you notice that they both multiply by 2, if we write this time 2 times 4, and this one is 2 times 6, and we cancel those out, notice we have 4 and 6, which are still even, which means we could have divided out a larger number. But that's okay as long as we keep going. So 4 is 2 times 2, and 6 is 2 times 3. So let's cancel out another set of 2's, and we're left with 2/3 as a final answer. So 1/4 plus 5/12 gives us 2/3. Now let's look at another couple examples. Here we are getting with some larger denominators. We have 15 and 24. And so if at all possible, I really don't want to have to multiply 15 times 24 to be able to get our common denominator. So let's actually take a look at using prime factorization to be able to find out what our least common denominator is. Okay, so let's move down here a little bit. And if we look at 15 and we break it down into the prime factorization, it is just 3 times 5. And we have 24. So you can do your factor tree for 24, but 24 is 2 times 2 times 2 times 3. And so let's look and see what they have in common. They only have a 3 in common, but since they're in common, we can kind of double them up. We only need 1 3 in our answer because it would cover both of them. And then we see what's missing or what's left from our 2 denominators. Here we have a 5, so we need to include that. And then here we have our 2's. So there we're adding 2 times 2 is 4, times 2 is 8. So let's put 8 over here, make it easier to write. And so the smallest number that we can use for the denominator is our paired 3 times 5 times 8, which is 120. So it's definitely smaller than if we were to multiply 15 times 24 and use that. Go back up here and say now that we need to change 1/15 into a fraction with 120 on the bottom. And we need to change 7/24 as a fraction with 120 on the bottom. And then we'll add our 2 answers together. So if we divide 120 by 15, we get 8. So it's 15 times 8 to get 120. So we need to do 1 times 8 to get our new numerator of 8. So 1/15 is equal to 8/20. Now, if we look at 24 to 120, that's times 5. So we will do 7 times 5 to get 35 out of 120. So now we can add those answers together. 8 plus 35 will give us 43, and that is out of 120. And 43 and 120 have no common factors, and so that is our final answer. For E, we have 3 3/4, and we're adding to it 4 1/5. With this class, what we are going to do is to go ahead and change them into improper fractions and then add them together, or change them to improper fractions and subtract them if it's a subtraction problem, so that way we don't have to worry about getting a whole number and an improper fraction and having to fix that, or when we're subtracting, have a smaller fraction subtracting a larger fraction and having to borrow and that kind of thing. To make it easier for us, we will just use our improper fractions because we will always be able to add or subtract those. So let's take our 3 3/4, and to change it into an improper fraction, we're going to do 4 times 3 is 12, plus 3 more is 15. So that gives us 15 fourths. And we want to add to it 4 1/5. So 5 times 4 is 20, plus 1 more is 21. So we're going to have 21 fifths. And we already had an example with 5 and 4 as our denominators, and we used their common denominator of 20. So let's go ahead and get our common fractions into 20. So for our 4, we know we multiply that by 5 to get to 20. So 15 times 5 gives us 75. And it was 5 times 4 to equal 20. So 21 times 4 will give us 84. And so when we go ahead and add that, we have 75 plus 84, which is 159. And that's out of 20. And when we look at 20, that's 4 times 5, we know that, or 2 times 2 times 5. 159 is not even. We can't divide it by 5 either because of the 9, so it can't divide by the 2, and it can't divide by the 5, so it is not able to be simplified, and so that's our final answer. Although if you do want to, you can change it into a mixed number. 20 goes into 159. Well, if you look at the 2 into the 15, that would be 7 times. 7 times 20 is 140. And so when we subtract, we get 19 left out of our common denominator of 20. So 159 20ths is our answer. Or if you write it as 7 and 19 20ths, that's great too. So here's our final example, 8 4/5 minus 3 1/5. And notice here we have a common denominator, so we do not need to change the denominator. But again, let's get into the habit of changing them into improper fractions. In this case, we could do 4/5 minus 1/5, and of course the 8 minus 3. But sometimes we could have the first fraction being smaller than the second fraction, and so we would have to change and fix things. But again, the easiest way to handle that is to deal with our improper fractions. So we're going to do 5 times 8 is 40, plus 4 more gives us 44 out of 5. And we're subtracting from it. 5 times 3 is 15, plus 1 more is 16, so 16 out of 5. And so we'll do our 44 minus 16 to get 28. And it's over our common denominator of 5. So 28 fifths is our answer because we can see 5 doesn't go into 28 evenly. It can't be simplified. But if we do want to write it as our mixed number, 5 goes into 28 a total of 5 times, which is 25. So it gives us 3 left over out of 5. So 5 3/5 is the mixed number equivalent of 28/5. Okay, so now it is your chance to try some of these skills on your own. If you have any difficulties, you can let me know. Your practice problems are on page 22 and 23. I had mentioned not having enough to subtract if you just try doing whole number minus whole number and fraction minus fraction. Number 8 is one that is like I mentioned. So again, make sure you change them into improper fractions so you can, sorry, so you can subtract without difficulty. So unless you have any questions, I'll see you next time.